All right. Welcome, everybody, to OpenCV Live. I am Satya Malik, CEO of OpenCV.org. And as you know, OpenCV.org is the nonprofit that maintains the OpenCV library, which is downloaded about 1 million times a day. Today, we have a very exciting episode. We are going to talk about Nanochat. And this is a piece of code that was published by Andrei Karpathy so that people around the world could learn end to end how to train an LLM, right? And this is presented by this presentation is brought to you by Big Vision. This is a consulting company that I run. And with us is Vinayak Gupta. Vinayak is one of our star engineers who has put together this presentation. He has taken the time to understand Nanochat, and he's going to explain to us the various bits and pieces that you need to know so that you can train your own model for about $100, right? And it is very educational. We will not be able to finish this thing in this episode, so we have split this into multiple episodes. But this is going to be a start. I think this is going to be one of the most educational topics because Nanochat itself is so informative that you'll love it. Okay, but before we start the episode, as always, we have with us Phil Nelson, who is the Director of Content and Creative at OpenCV. He produces the show. If anything goes wrong, even if it is our fault, it is actually his fault.
That's a sweet gig you got there, man. It sounds like good work if you can get it, right? Yes, I am your co-host with the co-most, the second banana who's second to none. I'm also your plus one and only. My dear friends out there, you know it's Mr. Nelson if you're nasty, but you can call me Phil, and I am here to remind you of a few things that we do on every single episode of OpenCV Live, which is the program you are currently watching. Sorry, my thing's making noise over here. The program you are currently watching, and we are having a real fun time getting the stream off the ground this morning. But one of the first things we do here on OpenCV Live is ask questions, take questions from you in the audience, and answer them later in the show. Post those questions wherever you're watching, over on YouTube, on Twitch, on Twitter, whatever pirate feeds we now have attracted since the show got a little bit more popular, YouTube comments, etc. I will curate those questions and answer the best ones, bring them up on screen later on in the episode. We are also doing a special giveaway to you out there in the audience. We're going to ask a trivia question in about 40 minutes after our presentation, and the very first person to answer that question correctly will win an OpenCV University course for free. You can see what courses are on offer by going to opencv.org/university. I'm going to give a quick thank you and reminder that OpenCV is a nonprofit organization that creates open source software, and as such, we depend on the support of our members and partners, such as the phenomenal people that I have just put on screen here. I'm going to full screen them and hide our little plea for lucre. Big thanks to ARM, RunPod, Intrinsic, FutureWay, JetBrains, RoboFlow, Hackster, 7th Sense, Google Summer of Code, OpenMV, Orbic, the British Machine Vision Association, Tangram Vision, Amped Software, Intuitivo, Rerun, the Edge AI and Vision Alliance, and Big Vision, because every company needs a big vision. And in fact, Big Vision is sponsoring today's episode. So go check out Big Vision if your company needs a big vision, which, they all do. You can support OpenCV by going to the OpenCV support page. That's opencv.org/support. We accept donations from individuals and organizations. You can become a member and maybe be on OpenCV Live yourself. I need to update these numbers. They're significantly bigger now. It's good when the number go up, you know what I'm saying? Over 150,000 subscribers on YouTube. Your product or service could be in front of all of the OpenCV global community. If you become an OpenCV member, donate to keep the library going. Help us out, and we'll help you out too as a special perk for your membership. I know also, Satya, there's an OpenCV University sale, holiday sale going on right now. So let's take a quick looky-loo at OpenCV U, if I can fit this on my screen. You want to tell people what we got going on here?
Yeah, it's our holiday sale for OpenCV University courses. I would highly recommend the Computer Vision and Deep Learning Master Program, which is a collection of 6 courses. if you do 2 foundational courses, we say that you're ready for for a career in computer vision and AI. Uh, you know, these are not short courses. These take time, right? The foundational courses, for example, will take you about 3 to 4 months each to complete. So this is like a master's, getting a master's from a top university, except that you can do it at your own pace. And also, to be honest, this is much more material than than you would actually get in a master's degree. So yeah, check it out for people who are serious about about a career in computer vision and AI. We have fundamentals of computer vision and image processing. We have deep learning with PyTorch. We have deep learning with TensorFlow and Keras. We have a course which teaches applications using transformers, etc. So loaded with value. Go check it out. We have 40% discount. I think it just launched today, the sale. So for the first 2 days, you will have the highest discount, which is the early bird discount, 40%. Go check it out if you are really serious about a career in computer vision.
All right. Yeah. Thanks so much for that. For some reason, I'm getting some more echo here, but I'm just going to roll with it. We're having some weird audio production problems here today. But yeah, go check out OpenCV University. Let me know in the chat if you're watching out there if the audio is echoing for you at any point, and I'll try to fix this. Inside baseball, also, I'm trying out iPhone continuity camera as a webcam to simplify my setup here in the Wizard Tower, and I think it looks pretty good. Let me know what you think in the chat.
Yeah, it looks very good.
I think let's get started, shall we?
Okay, let's get
bring up the
started.
screen share.
Let's share the screen, and I'll go over the first few slides, and then Vinayak will take over.
Okay.
And in the slide, Vinayak will also introduce himself.
Okay. I'm bringing up them slides. There we go.
All right. So as I mentioned, we are going to talk about Nanochat today. This is a code base produced by Andrei Karpathy, who was the director of AI at Tesla and also one of the founding members of OpenAI. And this is the best GPT you can buy for only $100. You are going to train it from scratch, and it costs only $100. Just imagine, right? We were so thrilled at the DeepSeek moment when they said that, okay, they have trained this thing for a few $1,000,000, and now anybody with access to some GPUs will be able to do this. And we'll also tell you later on that you can actually get these GPUs from RunPod. It requires 8x H100, which is, it costs about $25 an hour, that setup of 8 GPUs. And when you run it for 4 hours, you will be able to train a Nanochat GPT. And this is mostly for educational purposes, but this, I don't want to steal Vinayak's thunder while explaining. He's going to explain. Let's keep rolling. Next slide. Just as a way of introduction for people who are just joining today, they've never seen this show. My name is Satya Malik, and I am the CEO of OpenCV. And as I have already mentioned, that it is downloaded 1 million times, used everywhere, everybody and their grandmoms. And I say grandmoms because this is an old library. We have been around for 25 years. Use it. I'm also the CEO of Big Vision. This is an AI consulting company. A lot of people don't know that, OpenCV doesn't put food on my table. It is Big Vision, my consulting company, that puts food on the table. So if you have any kind of computer vision or AI problem that you want solved, please reach out to us at contact@bigvision.ai. And finally, I'm also the founding member of OpenCV University. This is the collection of courses that we just talked about. Okay, next slide. So Vinayak, why don't you introduce yourself? I mean, I'll give a short introduction, and then you can expand on it. So Vinayak is one of those, when I pitch my courses, I've mentioned that people don't care about years of experience. What people really care about, the skills you have. And Vinayak is a classic example of that category of people who, on the books, he doesn't have years of experience. But when he joined us, we gave him an entire project, right? An entire project to handle by himself. And we had assumed that, okay, we'll have to do some part of it, handhold him, etc. He ran with it, and he finished the entire project pretty much all by himself. And that is what we mean by saying that you need to have skills, not years of experience, to be a good computer vision and AI engineer. Okay, Vinayak, a short introduction.
Thanks for the introduction, Satya. Hello everybody. My name is Vinayak Gupta. I am a computer vision engineer at Big Vision, where my work focuses on the intersection of visual data and language models, specifically visual language models and 3D reconstruction. A huge part of my role is core AI engineering, so basically taking models, optimizing them for production, and ensuring they scale efficiently. So that's actually why I'm so excited to dig into this NanoChat repo with you today.
Perfect. All right. Little bit about Big Vision. We have been around for 11 years. We have served about 102 clients and completed 200 projects. These are projects, sometimes we are training models, but sometimes we have built entire systems. And if you are in the United States, there is a very good chance that you have touched our technology, because we did this ID card authentication project for 9 years, where when you authenticate yourself using an ID card, the verification, etc., whether the photo is real or not, whether the text has been manipulated or not, that technology we built, and it is in several banks and even in various parts of the government that I cannot name, but most likely you have touched that technology. Next slide. And we pretty much have expertise in the whole gamut: classical computer vision, deep learning, vision language models, large language models, 2D to 3D vision, and end to end, deploying the entire solution end to end, right, starting from scratch. If you don't have any idea on how AI systems work, but your company is interested in it, you must have the money. We'll work with you to develop the idea and produce a solution end to end. All right, so for people who stick around, we have two goodies. First of all, we have a PDF that we'll share with you, which is called Common Pitfalls in Computer Vision and AI Projects. And some of these things are non-obvious. You'll be surprised by some of the things why you will see that people take care of a few things, which you will see in the pitfalls also, but there are some non-obvious things that we cover, which can really help your projects. And if you stick around to the end, we also have, you'll also have the option of, next slide, a free 15-minute consultation for your AI project, right? So it will be me on the call, and you can describe your project. We'll answer you, and it cannot be a school project, right? It has to be a commercial project that you're interested in. You don't have to pay us or hire us for this project. I'll be happy to give you my ideas for 15 minutes, but no class projects, please, because there's just ton of those. All right. All right. So from here, Vinayak will take over, and we will learn about the various steps.
Thanks, Satya. So we are talking about NanoChat today, right? But the challenge at hand is that today most companies they rely on large language models, which are basically off the shelf. So they are powerful, but they are also black boxes. They are trained on trillions of tokens and billions of parameters and layers of abstraction we don't control or fully understand. So that limits how much we can optimize, customize, or innovate at a more fundamental level. Introducing Nanochat, the solution to all our woes. So Nanochat flips that black box model. It's a complete end-to-end blueprint for building a ChatGPT-like system that a small team can actually understand, modify, and run, starting at roughly $100. So by working with Nanochat, we turn AI from a black box into a white box. So our engineers can inspect the tokenizer, the data pipeline, the training loop, the inference stack. So basically every single piece of the puzzle. That visibility unlocks real optimization, better decision making, and faster innovation.
I would call it a transparent box.
Yeah, that's right.
So
So
long as it's not a
strategically,
Skinner box, I think we'll be okay.
So strategically also this lowers the barrier to enterprise AI. So it gives us hands-on ownership, technical depth, and optionality without requiring massive infrastructure or capital investment. So in short, NanoChat lowers the barrier to serious AI ownership. It lets us build, audit, and experiment with our own models on a micro budget and scale only when it makes strategic sense. So, like Satya said, this is an educational sort of project that Kapati had built, but it has a business aspect to it. So there is a massive ROI of owned AI. So NanoChat isn't about replacing our current AI tools. It's a low risk sandbox that lets us validate an internal AI strategy without committing to a multi-million dollar investment upfront. So from cost perspective, it gives us control instead of recurring API fees and unpredictable vendor pricing. We can basically understand our true cost per query and optimize it over time, while also improving latency and reliability. From a data and risk standpoint, everything stays in-house. So customer data, proprietary documents, internal knowledge never leave our environment, which strengthens security and puts us in a better position as regulations evolve. Strategically, this allows us to build models that understand our business, not just generic internet slop. So, fine tuning on proprietary information creates differentiation that competitors can't easily replicate. Just as important, it builds internal capability. So, our teams develop real expertise in how these models work, reducing long term dependence on external vendors and giving us more options in the future. This is also low risk, so we can experiment at a very small scale, roughly $100, learn quickly, and only scale further if the value is clear. So that makes this a disciplined business decision and not just a research gamble. Before delving into this project, we have to look over its creator, Andre Karpathy. So he has been an industry leader in AI, a founding member of OpenAI, and a former director of AI at Tesla, where he led the computer vision team for Autopilot. He's also a renowned educator who's famous for making complex AI accessible and is now focused on democratizing AI through Eureka Labs. So today we are going to be performing a speed run. So we'll set up, train, and deploy a functioning LLM using the NanoChat architecture. One thing that stands out about this NanoChat architecture, or the thing that, or the repo that Andre has made, is that good AI or smart AI does not require complexity. So complexity is optional. This isn't a black box API wrapper. This is the raw, unadulterated code for a transformer model. So it has a minimalist design. It basically consists the entire neural network definition in roughly 300 lines of readable PyTorch. And because there are no massive frameworks abstracting the logic, your engineers can modify the attention mechanism directly. It also serves as the ultimate white box, like Satya said, the transparent box learning tool, stripping away enterprise load to reveal the engine. So the first part of getting into it is actually installing the dependencies. So before you build the model, we need a clean and efficient workspace. So we are using a modern tool called UV, which is an extremely fast Python package manager to handle our dependencies. We'll be creating a virtual environment to ensure that our software doesn't conflict with other system tools. The script speedrun.sh is designed to just run right away on a blank box, start to end. So I think a bit of context as to why we are using UV. It's blazing fast, so it replaces pip and pip tools, offering 10 to 100 times speed ups. It is isolated and clean, so as any virtual environment is, and uh, it is one click ready. So we just have to run speedrun.sh from zero to hero instantly. This is a very crucial part of the discussion that we're going to have today. So the translation bridge. So what I'm talking about here is the tokenizer that is used by the LLM. So the basic problem is that computers, they don't understand words. They only understand numbers. So let's say if your input text is hello world, the computer does not understand that. So the computer has to sort of figure out a way to convert that into comprehensible numbers so that they can be processed further.
Yeah. Vinayak,
So
can I pause you one little bit, right? So, so for people who, I mean, I'm pretty certain most people got it, but for people who did not get it, you can go to GitHub and see the Nanochat repository. If you just type Nanochat, you will see the Nanochat repository, and you can install it using this mechanism, right, that was mentioned. And now we are not just going to go over the script. Speedrun is the script that comes in the Nanochat repository. We are also going to explain you various concepts related to LLMs that the script uses, and so that it is not just the script. We are also going digging deeper into what are the various parts of a large language model. And the very first part is a tokenizer. And this tokenizer, right, will go where it exists in the Nanochat code base. But first, we are trying to understand what is a tokenizer.
Yeah, thanks, Satya. So basically, our tokenizer breaks down text into smaller chunks called tokens, which are words or subparts of words. Before an AI like ChatGPT can read a sentence like "Hello World," the text must be converted to a format that a computer can process. So it's essentially a giant math machine, the computer's brain. So, like as mentioned in the slide, it cannot sort of do math on the letter H. It can do math on only numbers. So, tokenization is that translation bridge. It takes human text and converts it into a list of numbers called tokens. So, this is basically something which is very crucial. Like I said, so how we choose to chop up this text determines how smart or dumb the AI seems in specific areas. What's easy to miss is that tokenization is not just a technical detail, it's a business level. So it impacts training costs, so how many tokens you need to represent the same text. It impacts inference cost, model quality, and internationalization of the model. So how do we chop up this text? So there are three fundamental ways to do that. First, which is the easiest and the most intuitive, that is the character level tokenization. This I would call the too small approach. So every single letter gets a number. Let's say A is equal to 1, B is equal to 2, C is equal to 3, and so on and so forth. The problem is that the sequence of numbers becomes incredibly long. So I went to the store, a simple sentence like I went to the store becomes 19 tokens. This hurts AI because AI models have a context window, so a limit on how much text they can remember at once. So if every letter takes up a slot in that memory, the AI forgets the beginning of the sentence before it finishes reading the end. So you are left with an AI with no context at all, which is essentially useless.
Yeah.
The second method
Super
is word
relatable
level.
of AI, by the way. That happens to me pretty often.
Yeah, so that is
Forgetting the beginning of the sentence. You get distracted sometimes.
that's right. So coming back, so the second method of tokenization is word level tokenization. This is something that I call the too big approach. So every unique word gets a number. Apple gets one, run gets two, and so on and so forth. But the problem is that the languages are infinite. So what if the AI sees the word OpenCV? If that word wasn't in its original list, the AI crashes or sees unknown. So you can't possibly list every word in existence. So that makes it practically useless as well. So the third approach, that is something that is being used in most of the SOTA models, which is subword tokenization. So it's just the right approach, and it's also used by GPT. So this is the habitable zone. We break words into meaningful chunks. Common words like the remain one chunk. Complex words like tokenization might be split into tokenization, like you see here in the slide. So basically, it keeps the list of numbers short, which is good for memory, but also allows the AI to understand any word by building it from smaller parts, which is what we ultimately want to do. We want that the AI has pattern recognition capabilities so that it is able to reason and think better. So this is an interesting segment of this today's webinar. So we'll go through why AI actually makes weird mistakes. So many things users think are AI hallucination or stupidity are actually just tokenization glitches. So there is a reason why early LLMs couldn't spell backwards. So if you had you asked ChatGPT 2 or ChatGPT 3 to spell the word lollipop backwards, it might fail. To you, lollipop is 8 letters, but to the AI, lollipop is just one single token. The AI sees the token ID, but the letters are hidden inside the ID. So it has to memorize the spelling rather than seeing it. One analogy that I came up with to describe it was trying to count the number of threads in a rope without untwisting it first. So the model sees a woven unit rather than in the individual strands. Second edge
And you can
case,
try it, right? You can actually go to Hugging Face or someplace where you have access to that model. You can try it yourself, and you'll see that this fails.
yeah.
Okay.
So it's pretty interesting to note. The second edge case is that AI was bad at simple math. So if you would put a simple query like 123 plus 456 up forth and ask the AI to just calculate the sum, it would fail. So humans read numbers digit by digit, but tokenizers often chop numbers arbitrarily. 123 might be one token, 1234 might be two tokens, 12 and 34. AI has to learn math differently for every possible way a number gets chopped up. So it's like trying to learn addition, where sometimes 10 is a single digit and sometimes it's two digits.
Yeah. And the counterexample of that, right? Why did it get any math correct at all? And that is because of memorization, right? Because it has found some text somewhere where it says that 123 plus 456 equals the right answer, right? So those kinds of things, it was just by luck that it was doing the right, at least up until ChatGPT 2. That was the case, that the math, it was not supposed to do math, but people would ask it math questions, and a lot of times it would get right, and it would get right in spite of the fact that it is not supposed to be doing math, right? So that's something interesting, right? And part of it is just tokenization, right? It remembers these numbers not as numbers but as text, right? And that is why it had such difficulty. It still has difficulty with math. The cheaper models, at least, they have difficulty with math still.
Yeah. Yeah, coming to the next edge case. So, like why AI is worse at non-English languages. So this is something that I experienced myself as well. I was an avid AI follower back when GPT was released, and I would just ask it questions in Hindi, and it wouldn't give me a good answer. So this is something that I've always kept in my mind as to figuring out what happens behind the scenes. So the thing is that most of the LLMs are trained on English text. So they learn to make English word efficient. For languages like Hindi, Korean, Japanese, the tokenizer doesn't recognize the words. So it chops them into tiny, meaningless pieces. It also incurs a cost. So a sentence in English might cost 10 tokens, but the same sentence in Korean might cost 40 tokens. So this means that the Korean users fill up the AI's memory 4 times faster and pay more for API usage solely because their tokenizer isn't optimized for them. So this is something that is crucial to understand from a customer's perspective as well, because most of the big tech companies that are offering API access to their LLMs charge on a per token basis. So this is something to keep in mind. Yeah.
So
Another edge case.
there's also this uh, Korean language is a specifically good example, because Korean is what is called a language isolate, right? It is actually not derived from any other language. That's my understanding. Some Korean people in the who have better understanding of Korean language may chime in, but my understanding, we had actually worked on Korean OCR a while back, and for that we had to understand a few things about the Korean language, and we found out that Korean is not derived from any other language, right? It is a language isolate, and that is why you have to. It's not like, if you train a model on English, it can do reasonably okay on French, right? A lot of words are similar and they are related languages, but you will not find that kind of situation with Korean. It has to be trained on Korean language.
That's right. Yeah. Coming to the next, this is a very interesting bug that earlier LLMs used to have. So there was a guy named Solid Gold Magikarp. There was a user named Solid Gold Magikarp on Reddit, and the tokenizer and the tokenizer that GPT used was trained on Reddit data. So the tokenizer data had an entry with this name, but if you ask the LLM that you are using, that you use about this string, solid gold magic up, it would panic, hallucinate, or insult you. So this happened because the tokenizer was trained on Reddit data, and this
Also
user
very
used to.
relatable.
And so basically, the tokenizer learned to make this name a single special token. However, the AI model, the brain, was trained on a different data set that didn't have that user. So the result was that the AI had a button on its keyboard for solid gold magica, the token, but its brain had never learned what that button meant. So pressing it caused undefined behavior, essentially an AI brain glitch.
That's fascinating.
So now coming to the technical details as to how the tokenizer is built. So there is a concept called special tokens, which are control keys that help us make the AI more human. So I have listed a few of them in the slide. And basically, just like a keyboard has letters and control keys, and AI needs special tokens to control the conversation flow. So, where it needs to end the sentence, where it needs to stop, where it needs to pause, stuff like that. The next thing, the raw material that the tokenizer is given is Unicode and UTF-8. So Unicode is a standard list where every character in human languages is assigned an integer. So it's in technical terms, it's called a code point. So for example, the letter H is assigned 104, the letter E is assigned 101, and an emoticon might be assigned a larger number. UTF-8 is a way to store these integers as bytes. So these are computer memory units. So simple A, B, C letters take 1 byte, but complex letters like letters of different languages, emoticons, and special characters take 3 to 4 bytes. So this is the basic algorithm that's making all of this work. So this is pretty interesting. Actually, we can sort of tokenize and compress out here in the live demo as well, like as to understand how the um, larger tokenizers work. So let's say we have a stream of bytes that is on the screen. It's AAA BD, AAA BAC. So initially, the vocabulary that is built is one letter is given one integer. So basically, one letter has one token. So in this input stream of bytes, there are 11 letters. So the token count is 11 tokens. After that, we'll find the most common pair. So we'll see that AA appears 4 times. AB appears 2 times, BD, DA, AC appear 1 time each. So the clear winner is AA. So we merge and create a new token. So we add a new vocabulary entry called Z, which represents AA. So the updated string becomes capital Z ABD, capital Z ABAC. So there you go. I mean, we have compressed the tokens from 11 to 9. So what the code inside, what the script inside the tokenizer does is that it keeps on repeating this, keeps on finding the most common pair and merging it until we reach the vocabulary size limit. Uh, One thing when I was preparing for this, when I was studying about how LLMs work, was that why not just have a giant vocabulary? Like if the vocabulary is a solution to everything, why not just have a giant vocabulary? So if you made a token for every single number and every word variation, wouldn't the model be smarter? So the answer is unfortunately no. It's for three simple reasons. First is, and the most important, I think, is sparsity. So if, let's say, a random numerical uh, token called 748291 is unique, and the model might see it once in all of the internet. So it never gets a chance to learn what that token means, how it behaves with different, how it interacts with different other numerical tokens or alphanumeric tokens, and basically, it has no knowledge of patterns that are being formed underneath. So a model with a small vocabulary, the model sees the token 7 billions of times. It understands the token 7 perfectly. But a model with a huge vocabulary, the model sees the token 748,291 once, and it's just a random stranger. So the model fails to generalize.
Right.
The second
And this is
reason,
how students also learn, right? I mean, we don't memorize every word, like the word study, right? We have study, studying, studied. We derive additional meanings from the same word, right? So in our memory also, we are not storing them as different things. They are derived from some common words.
perfect. Yeah. The second reason is memory explosion. So the model has a lookup table, which is an embedding matrix for every token. So let's say 50,000 tokens, the table is manageable. But if we have 10 million tokens, the table becomes massive. And the model spends all of its memory just storing the dictionary with no room left for the brain layers to do the thinking. The third reason is the loss of structure. So, if apple and apples are two totally unique, unconnected IDs, the model doesn't inherently know that they're related. So, just like Satya said, I think by breaking them into apple plus s, the model learns that adding s usually make things plural, applying that rule to everything. So, it does not have to reinvent the concept of plurality every time it sees a word with the ending with the letter s. After that, coming to the infrastructure, so we are turbocharging the tokenization. So we are compiling a custom tokenizer written in Rust. So this isn't just about code, it's about strategic performance. So the reason we are moving forward with Rust is that it is high, it performs really good. So by compiling our own tool, we gain significant speed advantages during the data processing and the training phases. The memory safety is also a crucial factor in determining in what language we build our tokenizer. So Rust guarantees memory safety without garbage collection, preventing crashes in critical production pipelines. It is also OpenAI compatible. So while faster, we remain fully compatible with OpenAI standards like tick token for inference. And yeah, that's how we move forward.
So TikToken is the most popular tokenizer, right? But this library uses another tokenizer that has been written. It has another tokenizer which is written in this language called Rust, and these are the reasons why they are. So when I these things are fully compatible, like the tokens that are produced by the Rust code is exactly the same produced by TikToken, right? But
Yeah.
okay, okay. So while training, so this tokenizer also needs to be trained, right? As Vinayak had mentioned, uh, based on the vocabulary. So you'll have to give it some data to train on, and it produces the same tokens as tick token, but it is much more performant. And we care a lot about this performance because we have to we have to do this under $100, right? And that is why this additional piece of code is there in a different language. Most people may not know understand Rust, but it's just a programming language. You go through it and you should be able to follow it pretty straightforward. It's not that difficult.
So this is a technical detail, basically about the installation of Rust Cargo. We are also using Maturin, which is a bridge that allows Python to talk to Rust. And once this step completes, our Python script can import the custom tokenizer, just like any library, but with native speed. So we can use tick token, like Satya said, as like we can use our custom Rust based tokenizer with and run inference with tick token as we do it with other tokenizers. Um, so the thing that we want to talk about is why data matters. So we don't just train AI, we promote it. So we take a model through three distinct stages of education, basically using different types of data at each step to unlock specific business capabilities. The foundation, which is stage one, that is general intelligence. Stage two is adaptation, which is specialization. And stage three is instruction tuning, which is basically job training. So at stage one, the model understands grammar and logic, and it has some knowledge of word facts, but it is not tailored to do specific tasks or make sense of any query that you make. But in stage two, we train it with industry dialect, technical jargon, and context awareness so that it can answer your queries better. Stage three is basically job training. So we train the model. We tell the model about the behavioral rules, specific workflows, and reliable output and get reliable outputs. So now taking a deep dive into as to what I mean by all of this. In stage one, I think the data that we are using out here is FineWeb EDU, which has around 11 billion tokens. So it understands English grammar. The model understands English grammar, basic logic, and world's facts. The business limitation is that it is smart but useless for specific tasks. So it knows what a let's say it knows what a contract is, but it doesn't know your company's risk tolerance. The second stage is domain adaptation, which is very important if we are talking about industry level applications of trading an LLM from scratch. The data that you feed out here can be raw documents, which are unstructured, and the model's capability after this run would be domain specialization. So it will be promoted to a specialist. Um some examples of the data input that can be given, let's say in the legal industry, is in the legal field is 500 executed contracts, maybe in the form of PDFs. In manufacturing, 200, let's say 300 manuals and technical specs, and similarly in finance, healthcare, and so on and so forth. So the transformation that this causes is phenomenal. So we feed this text into the model repeatedly, and it stops predicting simple sentences, simple generic internet slop sentences, and starts predicting industry-specific answers. So it stops hallucinating general answers and starts speaking your dialect. So one really good example of this is that generic AI, it learns that in healthcare, PT might mean patient and not point, which is a general abbreviation of, PT is a general abbreviation of the word point. But if you're training your model for the healthcare industry, it should understand that PT means patient. In maybe let's say in legal, in it might understand that indemnity is a high risk topic. Coming to stage three, which is instruction tuning. So this is basically the data that is given out here is curated training pairs, so input and output, where we convert documents into behavior of the model. So some industry specific examples are in healthcare. The doctors spend hours and hours on end typing discharge notes. So they need to summarize 2 weeks of hospitalization, let's say, into a one-page letter for the GP. The solution is that you input the daily raw notes, output a perfectly formatted medical discharge summary. In the manufacturing industry, weird error codes, cryptic error codes like the one given in the slide, these delay fixes. So technicians spend days or maybe hours on figuring out what is exactly wrong with their machine. But the solution for that is that you type in the error code, the model gives the exact page reference and a simplified summary for the fix. Similarly, in the legal and compliance sector, reviewing non-disclosure agreements or vendor contracts can take hours. Lawyers keep missing non-standard clauses buried deep into the pages. So an LLM that highlights risky clauses and suggests edits based on the company's playbook is a very straightforward solution for this. In finance, analysts read 50 annual reports to write one buy sell thesis, which takes weeks. But an engine that digests those 10Ks and drafts the risk factors and growth outlook sections of the memo automatically is a very straightforward solution. So here, the transformation that we witness is fantastic. The model learns how to act. It learns how to pause, format, summarize, or critique, rather than just babbling. Business value is also produced, which is reliability. So the model produces output that fits directly into your business process without needing a human to fix it. So basically, the knowledge base that we are going to be injecting into our model so that it gains general intelligence is fine by BDU. So most of the early LLMs were trained on essentially a raw dump of the entire internet. So the problem is that the internet is full of slop. So SEO, spam, random code snippets, low quality forums, etc., etc. To feed our model, we are accessing the fine web EDU 100 billion dataset. So this isn't just a dump of the internet. It is a repackaged, shuffled collection of high quality educational content designed for efficiency. So the source is that it starts with the fine web dataset on which the original LLMs were trained. So those are basically 15 trillion tokens of scraped web pages. And it applies a filter and asks the question, is this page educational? Does it teach a concept logically? If it does, then it is added into that dataset. So the result is that the data set that looks like a random comment section looks less like a random comment section and more like a massive unorganized textbook. So coming on to the architecture of the data, so we have divided the data into 1822 shards, which are individual Parquet files. So each shard contains roughly 250K characters of text and is compressed to around 100 MBs. So we use Parquet, which is an industry standard columnar storage format, because it allows for extremely fast loading during the training process, preventing the GPU from sitting idle while waiting for text. We also strategically allocate resources. So while there are 1822 shards available, since we are training a model that has only 560 million parameters, in accordance with the Chinchilla scaling laws, uh, we assume that only 20 tokens are needed per parameter. So the math comes out to be roughly to 11 billion tokens, which these 240 shards of this dataset would suffice. So downloading more would just waste compute time on diminishing returns, and downloading fewer would leave the model underbaked. Uh, Talking a little bit more about the chinchilla ratio is something that is sort of academically validated. It is an industry standard. So purely increasing model size without enough data, it yields diminishing returns. So the golden ratio is to reach optimal performance for this size. We require, as I said, 20 tokens of data per parameter, which roughly calculates to around 11 billion tokens. So we will divide this training into 21,400 steps and processing roughly 500,000 tokens every single step. So this is how we initiate the download of this 24 GB training corpus. On cloud infrastructure with high bandwidth, this will complete rapidly. Coming to building the tokenizer. So the tokenizer that we are building out here consists of 65,536 tokens. So we analyze a specific data set to build a custom vocabulary. So larger vocabulary means expressing more meaning in fewer numbers. Then we look at compression efficiency. So efficient tokenization speeds up processing and reduces cost by shrinking the sequence length. The OpenAI algorithm, that is the byte pair encoding algorithm that we talked about in one of the previous slides, is being used. So it is being used with reject splitting. That is identical to the one that we're using for GPT-4. This is something that we'll use to benchmark this tokenizer. So despite having a smaller vocabulary than GPT-4, our specialized tokenizer performs well on our target dataset. So this highlights the value of domain adaptation. So you can see that in news, let's say, while in comparison comparing it with GPT-2, our tokenization has achieved a better compression ratio. So a compression ratio of roughly 4.8 suggests that we have taken 5 characters and converted them into one token. So this optimality that we have achieved is pretty impressive with in such a small time. One thing to note is that the GPT-4, which has a vocabulary, or the GPT-4 tokenizer, which has a vocabulary of around 100,000 tokens, it outperforms in code, math, and multilingual tasks due to the specialized focus of fine web, the dataset that we're using on English. uh, we also need, before getting into training, I think we also need to establish quality benchmarks. So before we begin the computationally expensive training process, we must establish a rigorous way to measure success. We use the core metric, which was mentioned in the DCLM research paper and is sort of validated by Andre as well as a standardized exam. So it contains multiple data sets which evaluate the model on different aspects of intelligence. So first one is common sense and logic. So can the model understand cause and effect and physical interactions? Second one is world knowledge. So does the model recall factual information correctly? And the third one is complex reasoning. Can the model solve problems it hasn't seen before? So the names that are given below these headings are the names of the data sets that are being that are catering to these aspects of intelligence. So this is basically script for downloading the evaluation suite, using which our core metric will be evaluated while training.
So, Vinayak, just to, some people may be wondering where do they get this code from. We have prepared a notebook that we will be able to share, right?
Yeah,
Okay.
yeah,
Do we have a link right now? Phil can share it so that people can look at this code.
sure. I think I'll share it on chat.
Okay.
Yeah, go right ahead. We'd be happy to pass that along. While you're doing that, we can take a break here for a moment and do our trivia giveaway.
Yeah.
Let's do that, shall we? I'm going to go ahead and hide your screen share and bring everybody back. Boy, I have been putting out so many fires on the back end here. I feel this has been a very eventful episode on the production side. Folks watching on Zoom know what I'm talking about. But yeah, I will share the link to the code here in just a moment. But before that, we are going to do our trivia giveaway. If you need a reminder or you're joining us for the first time, the way this works is that I will ask a trivia question based on today's presentation, and the very first person to answer it correctly in chat, wherever you're watching, either on Twitch, LinkedIn, YouTube, or Zoom, will win an OpenCV University course of their choosing.
Your tokenizer went off.
Yeah, exactly. You can see what courses are available. We're so professional here. You can see what courses are available by going to opencv.org/university. So, the last episode of 2025, and we're going out on a good one here. But if you have won in the last couple of months, please don't answer and give other people a chance to win. And so I'm going to go ahead now and bring up our trivia question. If it will actually upload. Okay. So earlier in the episode, we talked about ways to chop up text. What 3 ways did we discuss for chopping up text? There were 3 methods here earlier in the presentation. The first person to answer with all 3, we need all 3, in chat wins a free OpenCV University course. That's opencv.org/university. You can also scan the QR code that should be up on screen right now.
Did we get the answers?
Our trivia shark Martha says I have to stay silent.
Okay.
And spelling does count, folks. Spelling does count. Oh, okay. It looks like we got. I'm gonna let this one count. So we have an answer here. I'm gonna put this out to Satya. Would we accept letter instead of character?
Yes, I think
Is that fair?
it's fair. It's close enough.
Is it close enough? Okay.
Yeah.
Our winner this week then is Bruce Wright over on Zoom, who answered character, word, or letter, word, and subword, which were the answers we were looking for, but we will accept letter, word, and subword. So congratulations, Bruce, longtime viewer here, I think, possibly first-time trivia winner. Congratulations, Bruce. Please send 1 email to me That's Phil at OpenCV.org after you check out what courses are on offer from OpenCV University. OpenCV.org/university. The big holiday sale is going on right now. You can save some money and get some awesome education here on the wild world of the internet. So congrats to our trivia winner. I think we can, we got a couple of questions here, and then we can do a little bit more presentation if that sounds good to everybody. Lawrence Grigley asks on Zoom, I've seen that the 20:1 ratio for language models, is that also true for vision and image models? Who would like to answer this one?
I actually don't know the answer to that.
Okay.
Vinayak, do you have an answer?
I think I'm gonna have to check up on that.
Okay.
No? Okay. Wow, we got stumped here today. There's a first time for everything. Thanks for wrecking everything, Lawrence. Good question. We will look into this one, and maybe we'll answer it on the next episode.
Yes.
I am dropping the link to the.
So the
collab
okay,
notebook.
I'll give you this. I'll give you this. So when let's say you're training a vision language model, right? All the vision input is also converted to tokens, right? So we have vision tokens and we have text tokens. So I think it doesn't matter. It applies to both, right? Once the tokenization is done from images, you're going to tokens. So visual tokens versus text tokens, it doesn't matter, right? It's the number of tokens. So, but frankly, I'm just guessing here, right? So we'll have a better answer in our next episode.
Yes, which will be like 3 weeks from now. We can go ahead and get back to presentation if you want to share your screen again. Vinayak, and we'll do we'll go a little bit over, maybe like 10, 15 more minutes if that's good with everybody. Yeah? Cool. I'm taking your silence as complicity.
Yeah.
So just quickly going over what we've covered so far. So we have set up our environment, made the box runnable. We have downloaded the data, so got the pre-training text onto the disk, and then we have trained our tokenizer and evaluated it. So we have defined the model's alphabet. Basically, we have built the tools, downloaded the text, and logged in the tokenizer, and we are ready to train the base model. So I think we will cover. There's something left to there. This training left to cover in the next episode or the next part of this session. So something that we'll go over in that webinar would be pre-training, which will basically build a base model. So before training, we will download and eval bundle so that tests can run periodically while it is training. And then we kick off pre-training with the scripts that are given in the repository. After the pre-training is complete, which is the most computationally significant part of this process, which will take roughly 3 hours to train, we'll come to mid-training, convert the base language model into a chat-shaped model. So we'll train the model on conversational data, where the model adapts to a multi-turn chat schema with special tokens loosely following harmony style formatting. So this stage also deliberately teaches behaviors the small model won't reliably pick up from raw web text, like MCQs, like multiple choice test mechanics, which is mixing in MMLU aux questions. So MMLU is basically a data set, and a tool used formatting for Python, which will help later on GSM 8K, which is also a sort of a metric test to evaluate our model against. Then we will run chat evaluation at the mid checkpoint. After that,
Well, I want to talk a little bit about that slide, the previous slide. So pre-training basically is, when LLMs are trained, they are trained. The most common pre-training task is a next word prediction, right? So basically, and one of the things that people are very confused about is that how can this very simple task, given a bunch of text, you are predicting the next word that comes, right? Now, the benefit of this kind of thing is obvious, right? Because you don't have to label any data. For people who have a computer vision background, they may know that for anything, to train anything, we need to label a bunch of data, right? But in this formulation, where you have to predict the next word, you already have the whole text. So you just have to not show the model the next word and ask it to predict it. So this kind of thing is called self-supervised learning. So you just need to collect data, and the data itself has what the next word should be, right? So you don't have to do any labeling. So that's one benefit. But a lot of people think, how can this very simple task of predicting the next word have such powerful implications? How can it lead to some sort of intelligence? And the answer is actually this. I copied this idea, or this analogy from Ilya Sutskever, right? Let's say you're training an AI model, right? There's a mystery novel that it has been trained on, and the next word is, so the text says, and the murderer is, right? So you have to put a name there, right? But to get the name there, you need to understand the whole novel, right? All the different twists and turns that happened inside the novel that made to make that one single prediction. So there is a lot of intelligence that you need to be able to predict this next word, right? For example, you also need cultural context, right? If somebody says, "Oh, I killed it," doesn't mean that the person actually killed something, right? So all those things, the cultural context, the all the language nuances, that needs to be understood by the model for doing this very simple task of predicting the next word, which is the name of the murderer, right? So that's what happens in pre-training. But then you get this model that's only good at predicting the next word, right? How can you take this model to actually have this chat interface that we are so used to now? You keep asking the model, it knows what you're talking about. So that is basically this mid-training, where it is trained to have this chat-like interface. So that's what we will cover in the next episodes.
There are two things left there as well. So we'll also cover supervised fine tuning. So basically tightening the screws on higher quality conversations. So SFT or supervised fine tuning is another round of fine tuning on conversations, which is ideally higher quality, and it changes packing to better match test time chat formatting. So then we evaluate it again and finally try the model interactively via a simple web UI. Optionally, we can also implement reinforcement learning. So it will give a small targeted bump to the model's critical thinking abilities. We use an algorithm called GRPO, a simplified GRPO style loop, primarily to improve the model's performance on this math data set with critical thinking involved there as well. But it is computationally intensive, and it will take 2-3 hours more. So, like, it will exceed the $100 budget there.
Okay. Yeah, and this is a very common thing that you have whenever you use self-supervised techniques. You have to have some sort of supervised fine-tuning, so that it is not completely, supervised, self-supervised. You have some supervision in the end to improve the quality. Okay, let's go to the next slide. So we had promised that we have two gifts. Bigvision.ai/pitfalls will give you the PDF that I just talked about, common pitfalls in computer vision and AI projects. I think there are 16 or 17 of those we have listed there. And then you can also book a meeting, a 15-minute call with me, bigvision.ai/book15, so that we can have a conversation about an AI project that you're thinking about, or you are already underway and you're struggling with. So whatever be the case, you can have 15 minutes of my time, and we can discuss the projects that you're working on.
Very cool. Okay. Are we?
Yeah, so we are ready for questions.
Okay, great. Let me bring down the screen share and we can do some questions. Okay. Oh wow! So our guest, our trivia winner, in fact, Bruce Wright says he actually owns the OpenCV University Master Bundle already,
Oh, nice,
and
very
so
nice.
in a act of wonderful Christmas generosity,
Is is Bruce located in the U.S. or Canada? Somewhere
I
shipping is
think
easy.
Bruce is Calgary. I believe he's in Canada.
Okay,
But he would like to give his win, his course win, to the second person. And so,
congratulations.
yeah, I'm looking through the chat here. I think 1, 2, character word pin token. I have to do some quick math in my head to see. Okay. Oh, yeah, nice. I have seconds. 10:02:51, 10:02. Character words. So some people said character word token. That's not correct. It looks like our second winner here would be Darius Go1. Darius Go1. Character word and subword over on YouTube. So Darius Go1, if you're still watching, you secretly won our trivia contest today.
All
You're
right,
second in line, and our friend Bruce decided to be super generous. And
that's very generous of
yeah,
Bruce.
thanks a lot,
Uh,
Bruce.
Actually, Phil, if you could take Bruce's address, if you could send it, I would be very happy to send an OpenCV AI kit. This is not the latest version. This is a version that I had, from. This is the Kickstarter version, actually, the thing that came right after Kickstarter, and I had purchased a bunch of them, and I've been looking for worthy people to give it away,
All
and the
right.
last one is left.
Okay, I think it sounds
Okay,
like a
I'll.
good deal. Bruce, I'll hit you up over email after the show here. I appreciate it. Very kind of you, Bruce. It's a Christmas miracle. Everybody's getting something here on OpenCV Live before the holidays. So let's now turn to questions. We had some people asking, interestingly enough, today, because this is an educational, OpenCV University Big Vision episode. We had some people asking about a few months ago. We had talked about doing a Kickstarter for a new course, and they're, I guess rightfully a little bit wondering what the status of that is. Do you want to talk about that, Doc, so we can get them
So
off our back?
we made a yeah, we made a decision yesterday. So to be honest, we were overwhelmed because the things were moving so fast, right? That how do you create a course that doesn't get obsolete in 6 months, right? So so we had paused that. Okay, maybe we have to wait, right? So finally, actually, it was last night that I had a long meeting with Vikas Gupta, who is the director of OpenCV
And
University,
multiple
and we
time guest on this show.
yeah, yeah, and I have so basically we decided that we will. So in our consulting work, right, we saw that about half of the projects we are already using VLMs, right? Half of the projects, which is a very big sign that we should be teaching this as well. So we decided last night that okay, we are going to do the Kickstarter finally, and that would be tentatively it is January 20 is the release. When we start the Kickstarter campaign, and we'll just have to deal with how fast the thing is moving. We'll come up with some foundational material and then some material that is latest and greatest, but may not be as foundational. That would change, but at least when people learn about these foundational concepts, when new things come along, they would be able to interpret it, how to use it, right? Or even how to understand it. They would be able to understand the papers, the technology behind it. So yeah, so the short answer is that we will do the launch on January 20, most likely. Yeah.
Oh, right.
Yeah.
Sweet. I think people will be jazzed about that.
Yeah.
There's also I want to briefly mention to folks out there, many of the members of the OpenCV team will be in Shenzhen in January. We're headed to China to see our friends at OpenCV China, Dr. Shichi Yu, who's been on the show many times, And also, we will be, the OpenCV team will be joining a community event hosted by Seed Studio at their makerspace. So stop by there. We will post the registration link for the folks in China on the OpenCV newsletter and on the website later this week. And so we would love to see you there. It would be a lot of fun. We'll have stickers. We'll have good times and some small presentations from the team. So come check it out. Also, you will be able to win a Seed Studio Recamera if you join us there, or an Orbic Gemini, I believe. So thanks to Orbic and Seed Studio for providing some prizes for the community there. Yes, Darius, our winner, please just send one email to phil@opencv.org. Another question about the course, the upcoming VLM course. I think I know the answer to this one, but I'll let you take it. Would previous masterclass students get the VLM course added to their courses, or do they need to purchase it? Will there be any kind of discount or something for folks that bought the master bundle already?
There will be a discount for people who are purchasing the master bundle. But it's not going to be free, unfortunately.
It makes sense. I mean, like you said, I have a little bit of the inside knowledge in terms of how much work goes into making these courses, and like you said, if you don't want stuff that's going to be obsolete in 6 months, especially when it takes like a couple of months to build the course material.
Right.
It's like you're halfway into obsolescence by the time you're even really ready to release the thing. So that's a tough job, but the OpenCV U team does great at it. So let's see other questions here. So for what we've been talking about here, people are asking about like hardware requirements, processing requirements for some of the to be able to use some of the technology we are discussing here. Like, what kind of hardware do you have to throw at these kinds of tools?
So the Nanochat, the $100 that comes from basically 8 H100 GPUs. So H100 is these server class GPUs, which are, they're powerful enough that they were banned for sending to China. And you need 8 of them. The cost is, when you use 8 of them, the cost on various platforms like RunPod, etc., you would see it's about $25 an hour, and that takes about 4 hours. So that's where the number 100 comes from.
Dang. All right. I mean, still.
So these are pretty massive GPUs,
yeah.
right?
Definitely the kind of thing that could heat a decent sized home, probably, with all of the.
You don't need much for that. I had these 1090 ones that were like 7-8 years back. I had purchased a 4 GPU machine. I just could not run it. The noise as well as the heat, it would heat up your whole room by a few degrees, and in summer it was just not tolerable.
Oh, yeah.
So I put it in my
especially down Southern California. It can get pretty warm.
Right.
It's pretty cold. It's been very chilly in San Francisco this month, and so I've been, I notice when I'm playing, like I'll boot up a game like relatively recent, like Cyberpunk or Red Dead or whatever from the last like 3-5 years. I'm like, I just get close to the PC so it can like warm me up while I'm playing. I'm sure our friend Bruce in Calgary knows exactly what I'm talking about. Extravagantly cold in Alberta. So we've got another one here over in the chat. So you've talked about you talked earlier about in your consulting you're seeing a lot. You're using a lot of VLMs now.
Yep.
And can you maybe drill down a little bit without, of course, revealing any customer information? Like, what kind of uses are you seeing most prominently? Like, what are the things that people should be paying attention to in terms of what is being used a lot now and what you see being used a lot in the future?
Right. So let me tell you the general principle. I'll give you examples, but the general principle is that LLMs have world knowledge, right? So they have been trained on internet scale stuff, and they have knowledge about the world. When they see text, for example, if I give them text from the ingredients of a certain, whatever is there on a store shelf, right? Grocery store shelf, there is some product, and you give it the text from the label, it will be able to predict very accurately what product it is, right? Now, the vision system is good at looking at local knowledge, what is in the picture, right? So you extract, if you are able to extract that product, and then put this, use this text to feed LLM, the LLM would be able to identify this object in zero shot, which means that you have never trained an object detector for this product, because there are like 100,000 SKUs in a typical grocery store. But if you take a picture and do OCR on it, send it to an LLM, you will be able to identify what object it is, right? So that's, and VLMs basically combine these two things. They have world knowledge and they can visually recognize things. So that's a common thing where you want to do zero shot identification of things. It is able to do it. And depending on the way it is trained, you can also do video analysis. So you give it a few frames of a video, and it will be able to say what's going on, right? Or what is going to happen even, right? What is, if the person is about to fall, they will, you can actually use a VLM to predict that this person is going to fall. So think about it this way, right? Again, just to summarize, LLMs provide it world knowledge, the LLM part of the VLM, and the vision part of the VLM gives it the eyes to look at the particular image or a video to extract information from that particular video. And the LLM actually gives it world knowledge. You combine the two things, and you suddenly are able to recognize things without any training data, right? So you can recognize a shampoo bottle without any training data, because these two things are already present in the VLM. Does that make sense?
Yes, I think so. I'll let the chat decide if that was a sufficient answer, but I think that was you did a good job of summarizing it there. All right, I think we're at time here, and we have cleared out the questions. So I think now's a good time to wrap it up. Satya, you want to take us home?
Yeah. So I have before I do that, I also have a little plug. I've been experimenting with this with what is called AI generated content. This is something I used to play around with. Whenever I read a paper, I actually upload it to Notebook LM. It gives me a conversation about the paper. So that's one layer. Then I read the paper and then I understand it. So understanding something in audio format and then reading it, I felt that it was very useful for me because they would add a few things here and there which I might have missed. And then reading the paper, the two things combined gave me a better understanding of the paper compared to just reading the paper. So what I did was I took those things, right, those Notebook LM recordings, and I've created this AI generated podcast, which I publish, in our next newsletter. I'll be able to share it. But if you go to any podcast site, like let's say Apple Podcast or something, and look for artificial intelligence papers and concepts, you will be able to get that podcast. And I have also created a separate YouTube channel for it. Initially, I put it in my YouTube channel, Learn OpenCV, but then I moved it to a different YouTube channel because the people who had subscribed to Learn OpenCV channel, they did not sign up for this, right? So
yeah, they
I have
hate
a few
it when
episodes.
You do that.
Yeah, and I saw it in the numbers. The content that we produce natively, that is rated 97.5% positive, and the AI generated content is rated 75%, right? So
that sounds about right.
Which is heartbreaking. Which is heartbreaking, but I think it is very useful. So by separating the two content, the people who subscribe to AI, artificial intelligence papers and concepts, they are already subscribing to AI generated content. They know about it, and so it's an active thing. that is why separating the two channels made sense on YouTube. And of course, we have this podcast. So if you get a chance, check it out. If you don't like it, it's fine, but I find it very useful, so maybe you will too. And these are very deeply technical content. This is not introductory content, because I'm basically reading some papers. Sometimes I'm using old papers also, which I have read years back, but something interesting but very technical, and it presents it in a non-technical format, but it is the flavor is still very technical, right? So artificial intelligence papers and concepts on various channels.
Yeah, go check that out, folks. It's
Okay. Enough of that. I really want to thank Vinayak for this excellent presentation, and I want to thank Phil for organizing this. I know it was not easy today. There were a lot of technical glitches, but as always, you came through with your, magic. So thank you. And I want to thank our audience for sticking around this long. We went a little bit over, but I think that this was educational, and we are going to do more of these episodes in the next year so that we cover the entire Nanochat library.
Yeah, definitely. Thanks so much, everybody, and thanks to our guest here. I think first time appearance. So, and I think you nailed it. This is a very informative and educational episode. OpenCV Live is off for the next 2 weeks because it just so happens it's the perfect storm of Christmas is on Thursday and New Year's is also on Thursday. So we will be off for 2 weeks and are coming back on January 8th with part 3 of our popular SLAM Techniques series. And then we've got on January 15, we're going to talk about the low power computer vision challenge for 2026. We discussed with those folks last year. And on the 22nd, we've got Tangram Vision will be coming back, bronze members Tangram Vision, to talk about the latest in state-of-the-art camera calibration, a subject near and dear to the hearts of any computer vision engineer. And then probably on January 29, we will do part 2 of this episode here. And so we'll make sure to link these episodes together on YouTube as best as we can to make sure that folks can, at the end of it, they can watch all 3 together. It is, of course, the holiday season here in the United States. I'm going to do a quick plug of my own here as well. One of the things I do as a side project is I run a little independent streaming channel that is all built on public domain media, so old movies and TV shows. And we turned on all Christmas mode for the next couple of weeks on RetroStrange TV. You can scan the QR code or go to retrostrange.com to check it out. No ads, no trackers, no signups, no BS. Like, just go in there, push play. You'll be watching the video. This is a great thing to put on for your holiday party. It's all basically PG content. There's not going to be anything super wild in there. We've got some classic, Scrooge from 1935, TV version of the A Christmas Carol. We've got Vincent Price reading A Christmas Carol from I think the 50s. And we've also got one of my all-time favorites, the classic Mexican Christmas movie Santa Claus versus the Devil, where old Saint Nick battles Satan for the souls of children.
Oh, wow.
And it's a kids movie. It's a kids movie.
Movie.
It's fantastic. It's on right now on the channel. So please go check it out. It's free. I hope to see you there. If you drop in the chat over there, say hi. We will be broadcasting all until the day after Christmas. Will be all holiday stuff. And then, and also on Festivus on January 23rd, we're having a special 24-hour repeated stream of The Donuts, a 1964 short feature that we are mildly obsessed with at RetroStrange. So hope you join us for those things. If you drop in the chat, say hi to me. I'll be checking it out. And happy holidays to you out there from everybody at OpenCV, but especially me and Satya. I know. Take care of yourselves out there, folks. Take care of somebody else if you can, and have a great day wherever you may be. Happy holidays.